All right, let's go ahead and get started with example 3. So we're going to be finding the GCF of monomials. Ooh, fun. So find the GCF of each pair of monomials. So we have 15x cubed and 9x squared. Ooh, this is going to be interesting. Okay, so I like to do this in 2 steps. The first is the numbers and then the letters, right? So I want to break 15 and 9 into its prime factorization. So I'm going to take 15, right, and just break it down. That's the same thing as 3 times 5. This is prime, so I know that the prime factorization of 15 is 3 times 5. I'm going to do the same thing for the 9, right, which is the same thing as 3 times 3. Prime, which is 3 squared, okay? Or I might just write it as 3 times 3 for right now, okay? I'm going to do this I'm going to call this the long way. All right, I'll do it the long way first, and then we'll do it the short way after, okay? So the long way is to write out this entire monomial. So you would write the prime factorization of 15, right, which is 3 times 5. So I would write 3 times 5, and then x cubed is the same thing as x times x times x, right? That's the same thing as 15x cubed. I probably should have wrote that. 15x cubed equals that, okay? Not very pretty, but you get what I'm saying. Okay, then we're going to do the same thing for 9x squared. So 9x squared is equal to the prime factorization of 9, which I'm going to write the long way and just have it be 3 times 3. And then x squared is the same thing as x times x, right? So I'm just writing this whole thing out. So the greatest common factor is the things that they have in common. So what do they have in common? Well, they have a 3 in common, right? Just one 3. There's another 3 here, but it's not there, so that doesn't work. There's a 5 here, but there's no 5 here, so that's not common. But they have an x in common, and then they have another x in common there. There's one more x here, but there's not one in common there. So that's the greatest common factor, is the stuff they have in common. So the greatest common factor is equal to 3 times x, which is 3x squared. That's the greatest common factor. Okay? So that is the long way, is just by writing it all out. I think there's a benefit to writing it all out, is that you can really see those common factors and it gets a little bit, like, it just is kind of obvious, you know? Okay, so I'm going to do the short way. So the short way would just be writing the prime factorization. So 15x cubed is the same thing as 3 times 5, which is a prime factorization of 15, and then I'm just going to write x cubed, okay? And then 9x squared, the prime factorization of 9 is 3 squared, and then we got, you know, just x squared, right? So I'm just looking for the greatest common factor. So what do I know is common? There's a 3 here. I know that there's one 3 within that 3 squared, so my greatest common factor is going to have 3. There's not a 5. They both have an x. So what is the most x's they have in common? This is an x cubed, and so I know that this isn't an x cubed, right? So they don't have x cubed in common, but they do have x squared. There's an x squared here, and there is an x squared within that x cubed. So I know that x squared, and that's it. That's the greatest common factor, 3x squared. Okay? Long way, writing it all out. Short way. Okay, let's look at the next one here. So find the GCF of each pair of monomials. We got 8x squared and 7y squared. So I think what I'm going to do is look at the numbers, right? So 8, these are kind of really small numbers, so I'm going to do it this way. 8 and 7. So 8 is the same thing as 1 times 8, And then what, 2 times 4, right? Those are all the factors. And then 7, it's just 1 times 7. So here's all the factors of 8, and here's all the factors of 7, right? So what are the common factors here? It's just 1, right? That's it. So, and then what about x squared and y cubed? So if I was to do this the long way, right? So the long way, I'm going to do this the long way. So the long way would be to do the prime factorization of 8, right? Which is, what is 8? 2 times 4, this is prime, and then 2 times 2, right? So 8 is the same thing as 2 times 2 times 2, right? This is, oh, I should write 8x squared. So that, and then we have to do 7, right? 7 is just 1 times 7. That's it, right? So what do we have? 7y cubed. And so 8x squared is 2 times 2 times 2 times x. And 7y cubed is going to be just, 1 times 7. And then y times y times y, right? So I really don't see anything common here with the numbers or the letters, right? So there's nothing in common, but I have to think back to really like thinking about it this way, like 8 and 7. So they do have a common factor, right? The common factor, because 1 times 8 is 8 and 1 times 7 is 7. So their common factor, and really the greatest common factor, is just 1. So when there's nothing that is really super obvious, then you just know that the greatest common factor between those two numbers are 1. So they don't have another number or there's no letters, just the greatest common factor is 1. So that's the long way. The short way would just be to, break 8x squared. 8x squared is the same thing as 2 cubed, right? So 8x squared is equal to 2 cubed x squared. And then 7y cubed is the same thing as just 7, right? Or 1 times 7, or I'd probably just write 7. 7y cubed, and you just look, right? There's no numbers here that are in common, and there's no letters in common, so you just know that the greatest common factor is just 1. And that's it. Okay, now it is your turn to check it out. So here I want you to try example 3A, 3B, and 3C. Okay, so try all 3 of those problems. Here's my friend, the pause dragon. Remind you to pause your device. When you get done, press play, and we will go over your solutions. All right, I will see you in a little bit. Okay, let's see how you did on this first one. Check it out, example 3A. I'm going to go ahead and break these numbers down. So 18 is the same thing as 3 times 6. 3 is prime. 6 needs to be broken down to 2 times 3. Now we got prime. So 18 is the same thing as 2 times 3 times 3. I'll do the long way first, okay? And then 27 is the same thing as what? 3 times 9. That's prime. Break this down, 3 times 3. So it's really the same thing as 3 times 3 times 3. Okay? So let's break down. This is the long way. But I think sometimes just it's easy to see what the greatest common factor is doing it the long way. So I'm going to say 18g squared is the same thing as 2 times 3 times 3 times g, right? And then 27g cubed is the same thing as 3 times 3 times 3. And then times g times g times g. Okay, so now the greatest common factor is going to be the things they have in common. So there's a 2 here. There's no 2, so that's not in common. There's a 3 in common. there's another 3 in common, and that's it for the numbers they have in common. And then there's a G in common, and then there's one more G. So boom, that's it. That's the greatest common factor is 3 times 3 or 9, G times G, G squared. Okay, that's the long way. Let's do the short way. Short way would just be, what would it be? What would it be? What would it be? I'm going to write this in its prime factorization. So 18G squared is going to be 2 times 3 squared times G squared, right? And then 27 is the same thing as, well, 27G cubed is the same thing as 3 cubed, G cubed. And so my greatest common factor is going to be what they have in common, right? So they both don't have a 2. They both do have 3. So how many 3s do they have in common? We got 3 squared and 3 cubed. So we know that they have a 3 squared in common. And then we get to the G's. Okay, cool. Now we want the most G's they have in common. So this has G squared, this is G cubed. So that means they have a G squared in common. So that means that the GCF, 3 squared is 9. You would write it as 9G squared. So if you got that right and you did the long way and the short way, awesome, awesome. Okay, let's do this next one here. So I'm going to break down the numbers first. So 16 is the same thing as 4 times 4, which is the same thing as 2 times 2 and 2 times 2. There's all of my, what are those? Those are my, that's my prime factorization, right? So I'm going to write this as, you know, this is going to be the long way. So, okay, so 16a to the 6th power is the same thing as 2 times 2 times 2 times 2 times a to the 6th. And this is when the long way just becomes kind of ridiculous. 1, 2, 3, 4, 5, 6. Okay? And then we go to 9, right? 9 is the same thing as 3 times 3. So 9b is just going to be 3 times 3 times b. And then we just want to see what they have in common. So there's 2's, there's no 2's there, there's a's, there's no a's there, there's no 3's there, there's no b, there's nothing in common, which means that the GCF is equal to 1. Okay? The short way to do that, and I would much rather do this problem the short way, personally, it would just be, you know, 16a to the 6th is the same thing as 2 to the 1, 2, 3, 4, 2 to the 4th, a to the 6th, and 9b is the same thing as what? 9 is the same thing as 3 squared b. And, okay, there's no 2's in common, there's no 3's in common, there's no a, there's no b. GCF is equal to 1. Boom, that's it. Okay? So if you got that one right, awesome, awesome. Okay, let's look at this last one. Check it out, example 3C. It says find the GCF of each pair of monomials. So we got 8x and 7v squared. I think I'm just going to do this one the fast way, right? So I'm going to break down the numbers. 8 is the same thing as 2 times 4. That's prime. Break this down a little bit more. And we got 2 cubed, right? So 8x is the same thing as 2 cubed times just 2 cubed x, right? And then 7v squared. I know that 7's prime, so it's literally just 7v squared. Okay, so there's no numbers in common. There's no letters in common. That just means that the GCF is equal to 1. So if you got that one right, yoke-a-dokie-mashita, you did a wonderful job, and I'll see you in a little bit for example 4.